Welcome to class today. This is Teacher Olumide. So we have some question or past lists that we are going to be solving, and the first one is on loss percentage. So it says we should find. It says Linda sold a car for 84,000 naira at a loss of 4%. Now the question says how much did Linda buy the car? Now it's important to know that when you say how much did someone buy something, what it means in the context of the person buying is that what is the cost price. So that means you are asking for what the cost price is. But since the context of the question, we have that Linda sold the car for 84,000 at a loss of 4%. So we have that the loss percentage is equals to 4%. Then we also have that Linda sold a car. That means the selling price is 84,000 naira. Now we also need to remember that for you to have a loss, that means the cost price must be greater than the selling price. For you to lose in a business, it means you bought something. That means when you now want to sell it, the amount you are selling is smaller than how much it costs you. So for instance, you buy a biro for 20 naira, it costs you 20 naira, and you are selling for 10 naira, you are going to be making a loss. So I needed to slot that in so that we remember some of the basic principles that guide loss percentage. So we have that loss percentage equals loss over cost price times 100. So this is the formula we are going to be using. All right, so we already have our parameters. The loss percentage is given to be 4 already, equals, now your loss, like we said, loss equals cost price minus selling price. So that means the loss, we have our CP minus the 84,000 naira all over the cost price times 100. Now it's important to know that this is the same as all over 1. So by the time we have this, that means this is the same as 4 is equals to. It means this numerators, 100 needs to multiply the numerator. In a fraction, when you have 1 over 2 times 5 over 3, it means this 5 is to multiply 1. Or if I decide to add x plus 1, this 5 is going to multiply x, and it's also going to multiply 1. So having that at the back of our mind, it means 100 is going to multiply CP, which is the cost price, and we are going to get 100 CP minus 100 multiplying 84,000. We are going to have 8,400,000. That's 3 zeros and 2 more zeros all over CP. This is the same as over 1. If we decide to cross multiply, it means we are going to have 4 CP equals to 100 CP minus 8, 4, 1, 2, 3, 4, 5. So from here now, if you decide to collect like terms, this 8.4 million, if it crosses to the left hand side, since it is negative, it becomes 8, 4, 1, 2, 3, 4, 5. Then we have 100 CP minus, when it crosses the other side, yes, it becomes minus 4 CP. And that's going to give us 8, 4, 1, 2, 3, 4, 5 equals to, this will give us 96 CP. Alright, so if we decide to press our calculator for what this will give us, we are going to be getting, so we have 8, 4, 1, 2, 3, 4, 5 divided by 96. Alright, so that means we divide both sides by 96. and our CP will be 87500 naira. So this is the cost price that the item would have cost, or that Linda bought the car. Okay. All right. So the second question we have to solve says we should solve. This is an algebraic fraction. So the first thing we need to learn about solving algebraic fraction is our ability to find LCM. So since this is an equation, because of the presence of this equal to, if there was no equals to, it would have been an expression. Now from this equation, we have denominators of 3, 2, and 4. So first of all, we need to find the LCM. LCM is LCM of 3, 2, and 4 is 12. Now, what we need to do next is to say that we want to multiply through. Let's multiply through by the LCM. So that means 12 is going to multiply 4x minus 1 over 3 minus 12 is going to multiply 3x minus 1 over 2, and 12 is also going to multiply 5 minus 2x over 4. Now from here, 3 goes, that's 4, 2 goes, that's 6, 4 goes, that's 3. So that means we now have 4 brackets 4x minus 1, negative 6 brackets 3x minus 1. Then we have 3 bracket 5 minus 2x. Now from here onward, if we decide to open the bracket, 4 times 4x is going to give us 16x. 4 times negative 1 is going to be negative 4. Minus 6 times 3 is going to give us, and I said yes, minus 6 times minus 1 is going to give us positive 6. 3 times 5 is going to give us 15. 3 times negative 2 will give us negative 6x. So we can decide to collect the like terms. We have 16x. We have negative 18x. Now this negative 6x on the right hand side, if it comes to the left hand side, it becomes positive 6x. And on the right hand side, we have 15. If we take this positive 6 to the other side, it becomes negative 6. If you take negative 4 to the other side, it becomes positive 4. So from here, 16x minus 18x is going to give us minus 2x. And minus 2x plus 6x is going to give us 4x. So from here, we have 4x equals to 15 minus 6, that's going to give us 9. And 9 plus 4, that's going to give us 13. So finally, our x equals 13 over 4. And that is the final answer. Okay. So another question here, we've been asked to solve for x. It is quite similar to what we've just finished doing. So just like we did last time, we are going to be multiplying through by the LCM. So first of all, what is the LCM? So the LCM of these should be 30. So we multiply through. We multiply through by 30, which is the LCM. So if 30 multiplies this, multiplies 5 over 6. Alright, so from here, 3 in 30, that's 10. 5 in 30, that's 6. 6 in 30, that's 5. So if 10 should multiply, so we have 10 bracket x plus 5 negative 6 bracket 2x minus 1 equals to 5 bracket 5. So if we open this bracket, we're going to be having 10x plus 50 minus 12x plus 6 equals 25. So from here we can have 10x minus 12x equals to 25. If positive 6 crosses the other side, negative 6. If 50 crosses the other side, we have negative 50. So 10x minus 12x, that's going to give us negative 2x. 25, this is the same as 25, negative 56. And so we have from here to be negative 31. And finally, our x will be negative 31 for negative 2. So finally, our answer will be 31 over 2. So that will be the answer. Okay. Right, so the next question we have here is on indices. So we are just going to be applying some of the basic principle we have on indices. So for this first one, there is a principle that says if you have a over b raised to the power and the power is negative. So basically the principle just is interchange the fraction and you have b over a raised to the power of n. So the m has surrendered its power or its strength by interchanging the fraction. So that means anytime you have a negative power and it's a fraction, just interchange it and you'll be good with the answer. Alright, so if we want to solve this, that means this negative 3 here, the moment you change it, it becomes 125 over 27 raised to the power of 1 over 3. So the negative sign has disappeared by interchanging the fraction. So we have 4 over 9 raised to the power of half. And the next law we also need to apply is that anytime you have a power that is a fractional power, let's say m raised to the power of n, the law states that the denominator comes here while the numerator goes here. So what we have is that the denominator becomes the root. So from here now, we have that this is cube root 125 over 27 1 times. Now this other one, this square root itself is this denominator 2. So we are not going to write 2 here because this 2 indicates the square root. So we have 4 over 9 or raised to the power of 1. Alright, so to finally solve this, the cube root of 125 is 5 and the cube root of 27 is 3 times the square root of 4 is 2 and the square root of 9 is 3. So when we get to multiply this, we have 10 over 9. And here is the answer. Okay, the next question, it's also based on indices, but this time around we are going to be simplifying what we are given. So pretty easy. So we have 3 raised to the power of x minus 2 times. Now this 9 can also be written as 3 raised to the power of 2. So there is an x plus 1 there. Times this 27 can also be written as 3 raised to the power of 3. And the negative x. 81 can be written as 3 raised to the power of 4. Then we have 5x minus 3. Now from here now, we can say this is 3 raised to the power of x minus 2 times 3 raised to the power. From the law of indices, when you have two powers, a raised to the power of m, or let's write it this way. When you have two powers, m and n, the law says that the m will multiply the n. So that means the 2 is going to multiply x plus 1. So 2 times x is 2x, 2 times 1 is 2, times 3 raised to the power 3 multiply negative x is minus 3x over 3 raised to the power 4 times 5x is 20x minus 4 times 3 is 12. Now from here now, we can see that the bases are common for the numerator. We have basis of 3. So what we just do next is we add the power since we are multiplying the bases, because that's the law of indices, that when you are multiplying two bases, you pick one and you add the powers. So here we have x minus 2 plus 3x plus 2 plus negative 3x and over 3 raised to the power of 20x minus 12. Alright, so we can say this is the same as 3 raised to the power. So x plus 3x is 4x. 4x minus 3x is x. So we are done with the algebra. That's the aspect that carries x. Then we have negative 2 plus 2. That's 0. So that means we are done with that. Then for the denominator, we have 3 raised to the power of 20x minus 12. Now don't forget, when we are also dividing indices, you subtract the powers. So we have 3 raised to the power of x minus 20x minus 12. Now because what we have for this denominator consists of two sets of expressions, so you need to put a bracket here so that it becomes 3 raised to the power of x minus 20x. That's using minus to open the bracket plus 12. So finally our answer becomes 3 raised to the power negative 19x plus 12. And that's the answer. Okay, the next question, the same thing on indices, but this time around it's an indicial equation because of the presence of a constant. So right away, if you look at this numerator now, base 2, and you've been asked to multiply, that means you will pick the common base and you will add the powers. That's 1 minus y plus y minus 1 over 2 raised to the power of y plus 2. Now this 8 will turn into 2 raised to the power of 3, 2 minus 3y. And from here, we have 2 raised to the power of 1 minus 1 is 0, minus y plus y is also 0. So everything here gives 0. We have 2 raised to the power of y plus 2 equals to 2 raised to the power. If 3 should multiply 2 minus 3y, we are going to get 6 minus 9y. So we can say this is 2 raised to the power of 0. Division of indices means you subtract the powers. Minus y plus 2 equals to 2 raised to the power 6 minus 9y. So from here now, we can then say that this is equal to 2 raised to the power 0 minus y and minus 2. 2 raised to the power 6 minus 9y. And from here we have that this is minus y minus 2. This is 2 raised to the power 6 minus 9y. So finally, base 2 equals to base 2. We have the minus y minus 2 equals to 6 minus 9y. So we can collect like terms and say minus y. If negative 9y should come, that's positive 9y. We have 6. If negative 2 should go to the other side, we have plus 2. Negative y, that's minus y plus 9y is going to give us 8y equals to 8. Then y equals 8 over 8 and y equals 1. Okay, so we've been asked to simplify this question and we should leave our answer in standard form. So the way to approach this is, let's first of all take away the decimal. So if we're going to do that, it means we go 1, 2, 3, 4, 5. You take it outside. That means this is 275 times 10 raised to the power. We went outside 5 times 1, 2, 3, 4, 5. That's negative 5 times this one to 1, 2, 3. That's 8 times 10 raised to the power negative 3. Then we move 1, 2, 3, 4. That's 25 times 10 raised to the power negative 4. Times we move 1, 2. That's 9 times 10 raised to the power negative 2. Alright, so from here, we can decide to bring all the numbers together. That's 275 times 8 for the numerator and 25 times 9 times, for the indices, we have 10 raised to the power negative 5, 10 raised to the power negative 3 over 10 raised to the power negative 4 times 10 raised to the power negative 2. Alright, so from here, you can begin to see how to divide to reduce the terms that we have. So we can first see if 275, if there is a perfect number. So 25 can go into 275, that is 11. That means this is 88 over 9 times 10 raised to the power of, now if you look at this, this is the same as negative 5 plus negative 3 over 10 raised to the power negative 4 plus negative 2. Don't forget, you add the powers anytime you are multiplying two bases together. So you can see that 88 divided by 9, that's going to be like 9 in 88 is going to give us 9. That's 81 points. We find out that it's going to be 7777777. So we can say 9.8. That's if you round it to one decimal point. So we have times 10 raised to the power of, this plus times minus is going to give us minus. So this is the same as negative 5, negative 3 over 10 raised to the power negative 4, negative 2. So we can say this is the same as 9.8 times 10 raised to the power of negative 5, negative 3. That's negative 8, 10 raised to the power negative 6. And this is the same as 9.8. A shorter way to just do this is that if negative 6 should go up, it becomes positive 6. Or if you want to follow the law of indices, you say negative 8, you subtract the powers, and this will be negative 8 plus 6. So which is still the same thing as what we have in this situation. So finally our answer will be 9.8 times 10 raised to the power negative 8 plus 6 will give us negative 2. So this is the answer. 9.8 is perfectly in a standard form, so you don't need to change it. And that's our final answer. Alright, so the next question, we want to subtract 2255 by 6 from this. Now when you subtract something from something, that means this is the bigger one, obviously. So that's 20035 by 6 minus, yeah, 2255 by 6. Okay. If we are going to do this, 5 minus 5, that's 0. Now 3 minus 5 is not possible. We can't borrow from this guy, we can't borrow from this guy. So we come to borrow from 2. If we borrow from 2, it's going to become 1 because you have borrowed, and you take what you are borrowing to 0 is the base, which is 6. So we have 6. Don't forget, we borrow from 2, we sent it to 0, that's 6. But we have to also send it here as well. So borrow from this guy, it becomes 5. And when you send to this place, it becomes 6. So that means 6 minus, okay, sorry, we are not done with the borrowing. We still have to borrow, this is also 5. And we send to this guy, that is 6 plus 3. Don't forget, what we are sending to 3 is the 6. So 6 plus 3 is 9. 9 minus 5, that is 4. We are left with 5 here. 5 minus 2, that is 3. 5 minus 2, that is 3. And this one, we bring it down. So this is the answer in these 6. Okay. final question we are looking at today. We've been given 173 in base n equals to 81. So obviously 81 is in base 10. So if we're going to solve this, we have to convert the left hand side to base 10. So that's 1 times n plus 7 times n. Sorry. 7 times n plus 3 times n, then 0, 1, 2 equals 81. So n squared times 1 is going to give you n squared plus n raised to power 1 times 7, that's 7n, plus n raised to power 0 is 1, 1 times 3 is 3, equals 81. And from here, we can have that n squared plus 7n plus 3. 81 crossing to the other side becomes negative 81 equals to 0. So we have n squared plus 7n. 3 minus 81, that is going to give us negative 78 equals 0. Okay, so we have a quadratic equation up our sleeves. I mean, if we are going to solve that, if you remember, so we multiply these two together. That's minus 78 n squared. So we are looking for two factors of this, that when you multiply it, it will give you this, and when you add it, it will give you this. A very easy way to go about it is we can say negative 78, since 2 can go, but let's ignore the negative sign for now. 2 in 7 is 3, remainder 1 in 18 is 9, 3. It means 39 times 2 will give me 78, but 39 plus or minus 2 can never give me 7. So I divide further. 3 in 3, that's 1. 3 in 9, that's 3. So this 3 and this 2 is 6. It means 13 times 6 will give me 78. And I can also say 13 minus 6 would also give me 7. And 13 times minus 6. So easily, I can decide to use positive 13n, and I use negative 6. So if I go ahead to solve the question, I have plus 13n minus 6n minus 78 equals 0. And from here, n is common. If I bring it out between these two, I have n plus 13. Negative is first common, and 6 is common. If I bring out 6, I have n plus 13. So from here, I have n plus 13 n minus 6 equals 0. So we have n plus 13 equals 0, or n minus 6 equals 0. So from here, n equals to negative 13, or n equals to 6. But because we are dealing with bases, we don't have negative bases, so we can say n is equals to 6. So that brings us to the end of this solution. Thank you for joining us. God bless you.